Hello everyone, Ray here. Who do we have in chat? Well, while we wait for that, I will start explaining. So we are building the dice. The dice is a wonderful, very, very small 3D printer that, very small, very precise, lots of fun. I still don't have a good tagline for it. But yeah, so this is part 3. Step 1 was, here, let's do the down-facing camera. So step 1 involved assembling the, this is a Misumi rail, very, very precise, very, very smooth, very, very expensive, onto this piece of sheet metal, which is a stainless steel plate that was backing it. So that was the first thing. That was the first thing. The second step, and this is what I was going to do yesterday, then I ran into a little trouble. The second step was to mount these 2 printed pieces. Well, actually, not quite. So yesterday, I was actually going to do step 1. And step 1 involved, okay, so inside the rail, there are these pockets, these openings. And so we have our screws coming in from the bottom, if you will. And then here, we have to put in these slotted nuts, or Schlitzmuten. And these are about 6 millimeters, the slotted nuts, the Schlitzmuten. And the hole in the rail is more like 5.5 millimeters, or 5.6 or 5.7 millimeters. And we can't force them in because of precision. So we ended up sitting here watching me for about an hour, sanding these things with a drill. And that was a lot of fun. And it's wonderful to everyone who watched. Andrew, hello. How are you? Cool. So, yesterday's stream was an hour of me sanding these slotted nuts using a drill and a piece of sandpaper, and we got 7 done that way, and that was enough for this rail. And then the second hour was actually assembling the rail onto the sheet metal backing piece, very precisely, screwing all that together, and then starting to screw that to the printed parts and not realizing that it wasn't actually going together. So now, what I've done is, well, first of all, I found a better way to do the slotted nuts. So instead of putting the screw onto the drill, I put it onto the drill press, and then I went and ran the drill press and did everything with a file. So now I did 7 of them in 15 minutes, and then I did 7 more of them in 10 minutes instead of an hour. So that's already an improvement, and I only have a few left, and I'll do them some other time. But yes, here I have slotted nuts that are 5.5 millimeters in outer diameter, or less, and I have 4 in this bag that I still have to do. We should have enough for the current step. So, that's that. The other thing that I had to do was I actually had to thread the holes inside the plastic printed pieces here. So, depending on lighting, there's 4 holes, 1, 2, 3, 4, and they go fully through. And then here, we now have screws. So I had to go break out my taps So I used an M3 tap on my cordless drill, and these plastic pieces are now threaded. So this completes step 2. And the instructions that we're going off of is, if you search for Dice 3D printer, then you get a Instructable as one of your first Google results, and in there is a series of YouTube videos which show step by step, and that's what we're following. And they're in German, and then you can select English subtitles, which the creator of Dice, Renee, worked very hard on. And you know, I'm doing okay with those. So that's that. So now we're going to do step 3, or Schritt 3. Schritt. I think this is the German word for step. But I don't speak German, so I don't know. So we're going to be mounting the linear rail onto the y-axis. We have this plate here. This is one of many pieces of sheet metal in this printer, and yes, this is a 2mm thick stainless steel. This is actually going to be the very top of the printer, and as is common with fabricated sheet metal, in this case it's laser cut, it's a flat pattern. There is a good shiny side, especially after a nice oiling, and there is a not so good side that has the various you know, markings and residues left over from the laser cutting. So the bad side is going to be the bottom, and the good side is going to be the very top of the printer. Ow, that is sharp. That cuts very nicely. Yes. This is going to be the top. And yeah. And then when the machine's all built, I think I'm going to give it another nice polish and whatnot. Cool. So, large plate. We're also, the instructions call for M3 by 8 screws. And in this case, these are kind of like a button head. I'll show you in a moment. Now the thing is, the instructions use high-wind linear rails, but here we've got Misumi linear rails, and these are thinner. So we're actually going to go down to a 6mm long screw. And I am going to need 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12. Cool. I have no idea if I'm going to have enough of the things that actually require the M3 screws, but you know, we'll find out. Next, we're going to grab the two 120mm linear rails. If you get the set, or if you're sourcing yourself, either way, the design calls for a 140mm linear rail for the x-axis and a second 140mm linear rail for the z-axis. And there's two y-axes facing these way, and these are the two 120mm linear rails. Now, essentially what we're going to be doing is mounting the rails to the bottom. So remember I talked about the good side. This is the good side. The rails get mounted to the underside of it. So I'm going to flip it right now. And yes, this is the side with the slight laser splurf, if you will. Let's get started. So first we're going to take out the two 120mm linear rails from the packaging. And we're going to prepare them in this plate here. Now, the Misumi rails are already pre-greased, so we're good on that front. I just want to take them out, clean them up a little bit, wipe them down a little bit, and we'll get started. I like to keep things clean, so I wear gloves. Especially when I'm dealing with stuff that's got oil on it. I like it when the oil stays there. cutting. A bag within a bag, very nice. Lots of oil, and then also rubber bands to prevent the rail from, to prevent the carriage from going off the ends of the rail. I had that happen yesterday anyways, and knock on wood, or this is plastic, it all kind of stayed together. But yeah, good for keeping things in check. So, a lot of oil here. I'm gonna grab a random screw bit and just kind of try to pop some of it out. They do lubricate these things very thoroughly. I could imagine just getting a huge squirt into these two holes, and then that would just go from there. But yeah, it's everywhere. That's the first 120. Now we can get the second 120 out. Okay, we have these two carts. Awesome! Yes, they are smooth. Very good. You pay money for precision and high quality, and in theory you get something closely resembling that. Or somewhat resembling that. Time will tell. Okay, so one would think that the rails are ready. Okay. I'll just place it like this so not to scratch it, which will probably happen anyways. And let's get started. Okay. So, I'm going to put a rail on here. And we need our Torx driver. I have a T10 bit in here for this. T10. And we're going to need our slotted nuts. And the slotted nut goes into the hole here. And And the screw goes in here. And we start screwing. Our goal is not to tighten everything. We're going to keep everything loose and positionable. Very lightly. And we're just going to do the 2 holes at the ends, and we're going to come back and do all the other ones later. Right now, just the 2 holes. Slot a nut. Whoop! That would be the cart coming off the rail. Lightly secure. And we're back on. And we'll flip it, we'll do the other side. And I can wiggle this, I can angle this as I need to right now. Cool, let's do the other side. Prepare the cart, or we'll prepare the rail. And I'll try screw first, this time. Screw, holding the screw from the bottom. Inserting the slotted nut. Then getting in there with the screwdriver. And lightly securing it. And again, not tightening, just getting it enough to hold. And I still want to be able to wiggle this around. Okay. Screw. Screwdriver. This actually works better. Just put the screw on the screwdriver. Get that in here. Drop in the slotted nut. And lightly secure it. Again, lightly because I want to be able to reposition everything. Cool. I think now we're going to put in the rest of the screws, and again we'll just be very, very light. See, I can wiggle the rail. This is important. And it's smooth. Okay, let's do the other side. So I'm pretty much lightly screwing until it stops, and then I back it off just a little bit. That way it's still smooth. So 2 screws. and then I'll move the cart over and go do the 2 screws on this side. See? Still wiggleable, as I keep saying. Okay. I'm just watching the video with the subtitles quickly on the laptop. And yeah, step 3 ends with all the nuts and bolts there, but still being able to wiggle both rings. So that completes step 3. And now I had started watching step 4. So step 4 requires the X rail from steps 1 and 2. It also requires this thing, which he's calling the pressure part. It's a symmetrical 3D printed piece, and it's got some cavities, which I presume are for the belts. Remember, this is a core XY, so there are belts responsible for both X and Y, and they're all in this head area here. Okay. We're also going to need a metal piece, which I'm going to go get now. The metal piece is like so. This seems to match it. It has 8 holes, and according to the video, it looks like on one side, 4 of these holes should have a countersink, so that the screw head bottoms out in it completely flat. I don't seem to have that here, so I might need to go countersink this. I'm just going to check that there's not another piece that looks like it. Okay, so looks like we're going upside down with this, and we're positioning the carriage inside the pressure part. Yep, and that goes right in. And it's just a tiny bit lower than being flush. And I think that's roughly it. Oh yeah, because the Misumi carriages are a little skinnier, so that would probably make sense. Okay. did seem to bottom out there. I might be wrong. I think it goes with the rail down. Okay. This would make more sense. Rail down. Now this is flush. Now this can go on top. So step 4. Yeah, we're going to have to countersink this, whether I do it now or later. That's the question. Let's first find the appropriate M3 by 5 sink screw, as they call them. This is the one with the flat head that requires the countersink. So if we try this. Cool. One, 2, 3, 4. Okay. So the center holes should have countersinking in them so that the head is completely flush with the surface. I don't seem to have that in these, so I'm going to have to go countersink these later and adjust accordingly. But for now I've put the screws in and it did engage. So yeah. So we'll start there. Right now in the video he's just putting those 4 screws in. Andrew says, yes, we had 4 watching for a while there. And it looks like we're back to 2 now. So whoever else is watching, please do chime in chat and say hello. Wonderful. Okay. Okay. Cool. So 4 more screws. And it looks like we're going to be putting 4 more into the outer edges. So that's going to be threading into the printed part. So I'm going to be taking this plate off right now, because for the printed part, and I probably should have done this ahead of time, I'm going to need to run my tap through to thread those holes. So I put the metal aside. I'm just going to pop this out. And I'm going to get the rail out of the way, because we don't want any sort of dust contaminating these rails. I have my taps here. And I have my drill fully charged here. Cool, we have Hey Ang 50 chiming in, saying hello. I'm also in the middle of one of my college classes, so I won't be able to chat much. Well, thank you for joining us. Hello, and you know, try to learn something in at least one of the places that you're listening to. Cool. Okay, so for the tapping, and I'm going to turn the audio off for a moment so that I don't hurt your ears as you watch this. We can watch here, so audio going off now. Okay, audio's back on. Cool. Andrew says, Ray, if you're using OBS in sources, you can overlay your image on top of your main image. Yeah, I am using OBS. Do you mean for like the screen of the computer? So if so, then the thing with that is I have my main workstation over there, and that's what's handling my camcorder and my webcam, and the audio sources and all that. But I don't have a long enough cable to get from over here to a monitor over here, so I'll just put my laptop here. So yeah, I'm not sure what you meant. So yeah, so I do have some longer cables coming and whatnot, and then I'm going to be able to put a monitor over here, and then I can control it all from one computer. But right now it's just my laptop, which is not handling the stream, so yeah, no. But if you meant something else, please clarify. Cool. A little bit of cleanup. Okay, so combination tap and drill bits from Harbor Freight, 13 bucks. See if you can find a sale. I'm usually bad at snagging sales from Harbor Freight. But yeah, I couldn't find my normal set, so I drove down and picked one up earlier today. So 4 holes here, another 4 holes here. I just went ahead and tapped all 8 of them. Short bursts, low speed, go slow. Because this is thermoplastic and that is going to heat up a lot, so you don't want to overheat it and melt it. You actually want to form the threads. So yeah, cool. So now we can go ahead and do all this again. First, I'm going to give it a quick puff of compressed air. It's nice blowing it all out. Okay. Ooh, little piece of printed. Alright, that's cool. So this is going back on here now. These are going to go back on here. And I'm just going to keep these center force screws light. Because I'm also going to screw in the 4 outers. The way this build is typically working out, at least so far, is I stream in the evening. I'm on the east coast of the United States, so, you know, meanwhile Renee is in Germany. So I stream, he's asleep, then after the stream's over, I message him and I say, here's everything I did, or I guess he watches the stream, and then I ask him, what did I do wrong? And he tells me everything I did wrong, and then I try to correct it, and I'll explain it next time. So for example, I'm going to be asking him about the countersunk holes and the screws I'm using here, because it doesn't make sense that, see, all the screws stick out right now. They're not flush with the surface. But the instructions say to use the same type of flathead screw that would require countersinking for all the places. But the center 4 holes would have countersinking, but the other 4 would not. So I'm a little confused there, and I'm just going to keep it like this for now and keep going. And then if some combination of countersinking or different screws is required, I can swap that out tomorrow morning. And that will be fun. So right now I'm going to continue following the instructions. So now, it looks like we're going to be combining these. Screw one to the other. One moment. Again, I don't want to scratch up the nice metal that will be visible as the top of the machine, so paper towels. Now I can drag it without fear. I can put this here. And we're going to hold this one of the ways. It's this way, it's upside down. Okay, I understand now. So we're going to be using the flat countersunk screws on this, which does indeed have countersinking. So, wonderful. And we'll just get everything started. So this is a web camera, so I can't zoom, but I can lift and show you all. So left and right is our x-axis, and then up and down is our y-axis. And inside of the blue area, there's 4 countersunk holes on that bar that's going left to right. And that's what the screws are going to be going into right now. Again, we're just going to go very lightly. We're just going to engage all 8 screws. And yeah, we'll start there. And I will do something, once I figure something out, about how to keep my head out of these shots. See, the camera is right above me, and I can't see anything unless I lean over, so it's wonderful. Very, very loose. Very loose. And in the subtitles for the step Renee is writing, it's a bit fiddly, but I promise you it gets worse, remember. That's true, this is going to be a very interesting build. If you want to gamble a couple of $1,000s on something that may or may not work, I kid of course, but this is a great way to do it. And of course I'm joking, but yes. Okay, making sure we're not cross-threading anything or anything like that. It's all very, very fiddly right now because we're smooth in 2 axes. I'll loosen up just a little more because... Okay, that's good. Just run the video for a moment to catch up. I should, like, you know, put some spacers under here so that the motion is free. See if I can find something. I have the little rubber rings. Start there. That is just barely enough that we clear everything. Wonderful. Even the garbage parts have a use. Cool. So, scrolling past, I'm watching the remainder of these 8 screws be put in. Griffin, hello Griffin. Griffin's asking, how tight are the holes with respect to the screws going in? Okay, do you mean like if it's an M3 screw, is the diameter of the hole like 3 millimeters or 3.2 millimeters? Like that clearance? Is that what you're asking about? Ah, this is nice. That little plate at the bottom of here actually catches against the metal frame, so I can't exceed the end. This is wonderful. So we're not going all the way to the end, we're just going a little bit. And we're going to start tightening a little bit here. I like to do it diagonally, in an X. Just very lightly, just until it's barely touching. We're doing that. And now we'll go do this. Yeah, so Griffin is asking about that clearance. There's some room to maneuver. It's the holes are countersunk from the top, so where it was 3 millimeters is now the sharp end of a conical section. So there's clearance. 3.2, let's say. I'm waiting for the video to get to the point where I can tighten the left side. I think I'm just going to do the left side and then I can be told how wrong I was later. So 1, 2, 3, 4. And now let's see. So everything's very smooth right now. Ah, see, it hits. This is good. And here I can go over the end, so we're not going to do that yet. Okay. So the idea is we want smooth motion. So the idea seems to be that we're going to, the head is here up towards the end, but not fully up, so I've backed it down a little bit. I'm going to tighten one screw here, the first screw for one rail. And now it gets tight. So that wasn't it. And I will try to tighten this again. And now we seem to be okay. This is good. Okay, so the slightly difficult to understand German to English subtitles I'm not 100% clear on which order, but the idea just seems to be which order to tighten the screws holding the rails in, but the idea just seems to be that we want smooth, controlled motion and it's not going to bind. So I'm going to bring it down here and I'm going to tighten the screw that's under here right now. And once again, I'm just going to see what the result is. And we're still smooth. Now I'm going to go back to the top. Remember, I like those X's. I'll tighten the third screw. Now I'm going to go do it again. I feel a little more load here, but we're still good. So I might as well just try tightening the fourth screw at the bottom here and seeing what happens. Yeah, I can feel slightly more load. Whoa. Okay, so the cart came off. This is wonderful. This is that thing that's not supposed to happen. So we're not going to force anything, so we're going to loosen the screws, holding the rails, and we're going to try to get everything back into shape. We're off. Okay, and we're back on, and we're going to repeat this whole cycle over now. Okay, let's do it this way. Slide inclination right. Tighten. Test. Clear enough. Going bottom. Tightening 2. Testing again. Going up. Tightening 3. Still smooth going down. Tightening 4. Okay, this is where we were, and I'm going to try not to lose the cart this time. And yeah, it's slightly stiffer, but this is about 10 times better than any of my other printers, and none of my other printers even run rails. So yeah, you know, this is good. I don't know where the logic of that statement was. So again, just lightly, but we're going to tighten the rest of the screws now and see where we get to as a result of that. Yeah, I'm pretty happy. There's no outright binding. Whether it could be slightly smoother, I mean, it probably always could. But yeah, we're good. Yeah, this is only one rail. This is going to be smooth. Yeah, we're good here. Cool. I'm going to take another quick pass and check that these screws are tight. They are. Do that. Cool. Alright, back to the YouTube video. So I'm just watching him secure the remainder of these screws right now. And we do seem to indeed have smooth running carriages, which is usually always a good thing. Balance this so I can just hold it by the head. There we go. Hey, it's balanced. But you tilt it and you screw it up. Cool. Water. Okay. So I'm not going to do this now, but the idea seems to be that we're going to take the screws and the nuts out one at a time, and we're going to use Loctite Blue, which is a medium strength thread locker. He's using 243. I was able to get from Home Depot here 242, you know, $5 on Amazon roughly. And if I'm understanding correctly, the idea is one at a time. We're going to take the screw out, we're going to put some Loctite on the thread, and then we are going to re-secure it. And then we'll just keep doing that. He's showing it first for these screws on the inside of the blue, so the ones that come down from this view. We just seem to want a little bit of Loctite. No puddles, just, you know, slightly. And yeah, right now he's doing the 4 screws on the inside here. And the idea is we do this and we make sure that whatever adjustment we made, we still have all smooth running. Which is fine. I mean, you take one screw out. Even here you have 3 more screws that were tightened, at least to some extent. You try tightening it now, tighten all of them now, make sure it still runs smooth. Then go back 1 screw at a time and Loctite it, but you know, that's the idea. Okay. So that concludes step 4. Step 5 is going to be interesting because you're supposed to you're supposed to use a 23mm long screw for 2 of these flange bearings, except there's no such thing in the common market as a 23mm screw. So we have to cut it down, and I was assuming that there would be a 25mm long screw in the kit that I could just grind down a little bit, but for the M4s I was only able to find a 40mm screw. So this is going to be interesting. Let's see, I want to, so now I'm starting the YouTube video for step 5, and I have to change my subtitle settings to English, because I do not speak German, but I do know now how to say the word for slotted nut, Schlitzmuten, Schlitzmuten, Schlitzmuten. If it was that last one, Renee should let me know, because I'm very much so enjoying learning how to pronounce this word correctly. Okay, we're going to need some fun stuff here. One of the things in our kit of parts is a MR series flange bearing. I will bring some parts out here. This is my hardware bag that is not the screws. So all the screws are laid out over there. And these are our flange bearings. I'll take them out and I'll show you later. I'm going to need 8 or so that balance of 10 should be fine. I'll actually start off with the semi-filled one, and then we'll move over to that. So that's one thing. I'm going to need 8 of the flange bearings. It's MF104. we're going to need 6 M4 washers. M4 washers. Let's see if I can say this. First, I'm going to use the Americanized pronunciation, Unterleg Scheibe. Scheibe. Interesting, in Russian, the word for washer is просто Scheibe. Scheibe. It is similar sounding to, like, I guess, marble or something. So yeah, Unterlegscheibe. Legscheibe? Unterlegscheibe? I don't know, maybe I'm close to fluency, maybe I'm completely butchering it. I'll find out, I'll hear about it one way or the other. So this will be fun, okay. Yes. We should have a class. Technical German. German for 3D printer builders. Because all German is technical. Yes. German for 3D printers. 3D print builders. German for dice. Yeah, seriously, there should be a crash course of how to speak German just enough so that you can understand how to build a dice. Woohoo. So we have our M4 washers. Okay. We're going to need 2 M4 screws that are 23 millimeters long. This is what I was talking about. Because I have these M4 screws. These are more like the Torx. These are the button head, which is how I call them. These are 40 millimeters long. So that's good. And yeah, I was under the impression, and for the 23 millimeter, they want a countersunk one. Yeah, I'm just gonna look again. Oh, here we go. I have it. I have M4 by 25, which I finally, for the third out of 3 times, I was only now able to find it. These are 25s. And yeah, I'm going to probably be grinding them down to 23 millimeters. And if I was able to find these earlier, I would have had that prepared. But, you know. So, we'll just kind of figure it out myself. But yes. Countersunk, flathead. Flathead is the American word. They're referring to them as countersunk head. I guess that's cool too. And these are all Torx, which is fun. Let's see, do I have anything larger than a T10 Torx? I have T15, and that seems to be what drives these. Woohoo! Cool. About $7. You get this little combination Torx driver from Home Depot. Life is good. Yeah. Trying to figure out what's going on here. I know we're doing something. I don't know what yet. It seems like we're taking okay, so the suggestion seems to be that we are going, so the suggestion seems to be to put the nut on, then grind this down, and then you'll be able to take the nut off. We're not going to like polish or try to chamfer the end because we need every last thread that goes all the way to the end. We're also going to be getting 2 more sheet metal plates that I'll fetch now. these guys. And let's see. These have 5 holes, and on this one side they are all countersunk. Both are identical. And I will consult M4 washers, flange bearings, 23mm long screw. That's all the fasteners that we're going to need here. So, for fun, we'll do it with 25. I'll learn how to do it wrong. Then I'll go back, I'll fix it up with the 23s. It looks like we put our quote-unquote 23mm long screw through the center hole here. Center hole. And then we go and put a washer, an M4 washer, on it. So he's now talking about how there's a like a smooth side and a sharp side on each washer, and I have no idea which is which, but I guess in the direction of the plate I'll go with the clearest interpretation, and then I'll learn how I'm wrong later. Going back a moment. So now we'll get into the very, very small flange bearings. And the concept of a flange bearing is it's a bearing, and in this case on the bottom there is a lip. You can see it here. So here the lip is going to go on the bottom, right? Like we're creating an open close, almost like a sandwich. And this is a path for the belt to run on. So 1, 2, open, close. Because the flanges are opposite each other. Now we're going with another washer. And this time it doesn't matter how we put the washer on, so we'll just do that. And we're going to put 2 more flange bearings. Same idea again, we're creating a belt path. So the lips are here. Put that up. Okay. And then another washer, this time the sharp edge to the outside. So yes. There is going to be put some Loctite on the Loctite on the very end of the screw. Very little. Very little. Tiny dab on. So we have this set now of plate, washer, 2 sets of flange bearings, another washer. We're going to be inserting it into one of these areas here. I'm just waiting for the video to show which one. Take the combination. And I can see the order. So I'm going to go sideways and we'll see what happens. the entire threading is happening to that bottom plate that the X rail is mounted to. So we can't bottom it out because the rail's there. But we also can't shorten the screw too much because the entire engagement happens in the 2 millimeters, which is the thickness of this sheet. That 23 millimeters has to be very precise. Maybe we'll just run 1,000 23 millimeter screws and life will be easier. Cool. After this is tightened somewhat, you'll want to make sure that you can still spin all the bearings, that it's not over tightened. Cool. We're going to build the other one right now. Again, countersunk side out. Screw. The consensus seems to be, so we're going to need a total of 3 washers per side, 6 total for the step. The consensus seems to be sharp side of the washer facing towards the plates. So here the sharp side of the bottom. Sharp side of the washer is going down with the screw up, so to the plate. I'm going to open up my other thing and pull out 4 flange bearings. Build our sandwich. 1, 2. Washer does not matter which way the sharp side goes. Flange bearing 3, 4. Again, with the screw facing up, washer with the sharp side facing outwards. I have to clean this screw up because there seems to be some dirt of sorts on here. We'll get the paper towel. It's probably more of a grease than dirt. I don't know of any yellow grease that I've encountered in this kit yet. And unless something's different, we're going to be attaching that onto this side. I'm just going to do it while I wait for the video to catch up. Lots of fun. Don't worry, this is the easy part. The hard part's later. I'm just loosely tightening it for now. Yep. Screw is loose. And continuing to fiddle with all this. We've used all the fasteners, so I don't think there's anything more to this step other than just, Yeah, so in the next step we're going to be screwing the remaining holes in these plates. Okay. Step 6. in your YouTube video. Hey, we got English subs this time directly. Cool. So we're going to be using countersunk bolts, M3 by 10 millimeter. This makes sense. So we have M3 by 10 millimeter, as we would say in America, flathead, and we are going to need 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Cool. And I'm going to make some assumptions that it's a fairly straightforward thing of thread into the plastic, which we already did. We already tapped the plastic. Get some motion going. I'm trying to get the screw to go vertically. I'm going to have to undo all this to then go fix it with the screw, so I'm not going to thread all the way in right now. I just want to see how far this goes, right, in a manner of speaking. Cool. Got 4 screws in here, not tightening anything right now. Over here, these 2 went in. These 2, the threaded hole in the plastic is kind of gunked up with little plastic spirals. So that's that. Okay. Let's see about step 7. That is mounting the flange bearings, more of these guys, to the frame. So hopefully it does not build upon, but rather builds to the side of this. Step 7, we need a steel scale, a ruler, okay, or anything else to measure. Okay. I have rulers. I can go run downstairs and grab a ruler. You need 4 connector blocks that you can make out as pressure parts. It's showing a printed part and aluminum. Okay, so 4 pieces. So I have the aluminum parts. It looks like we need 4 of these aluminum parts right now. It's a rectangular prism block, CNC milled aluminum. I seem to have 9 of them in total, and there's also 2 of a different larger size, and it looks like we need 4 of them right now. 4 pieces. We need 8 screws, M3 by 8mm pan heads. We have them. I don't know if this is actually going to read. No, I think I'm done with my German pronunciations for a little while. Okay. And we're going to need 16 bearings. So I've got 6 in here, and I've got a full set of 10 in here. So that will be fun. Okay. This tube's empty. It goes back in the bag. The bag goes to the side. 8 M4 by 40mm. I have that here. The bag says 8. 1, 2, 3, 4, 5, 6, 7, 8, and we have 8 of them here indeed. This is good. Apparently, I don't see any washers here. We do need, it seems, this, he calls it air hose. I'm going to just call it, like, silicone tubing. This is a 4mm inner diameter, 6mm outer diameter. And according to this, we need 4 pieces that are 4mm long, 8 pieces that are 13mm long, and 4 pieces that are 22mm long. Huh. Yeah. I have an idea. If I try to actually, measure this using a caliper or a tool and cut accordingly, I mean, I've done this with PTFE tubes to precisely measured items for the Bondtech and E3D Titan extruders. It's like you need a piece that's, 22mm long. Yeah, 22mm. Now it's going to end up as 24.5mm and is going to get compressed inside there. So I'm actually thinking I might design up and 3D print some quick blocks that have, just a hole for this to go into with a wall, and we can do it for 4, for 13, and for 22mm, and that way I can just go get a clean edge of this, and then I can insert, I can cut at the wall, I can just get my knife against the wall and make these. And that should be more helpful, and that's going to take some time, so I can do that later this evening. And then I have to go back and fix the 25mm screws to 23, confirm with Renee about the countersinks in the plate and how we're going to play that, potentially double check the CAD model, but I don't think the screws for this were modeled in, so I gotta look into that stuff. And yeah, so I think we're going to call it an evening for now. So we're only an hour 22 in, which is, I think, yesterday was 2 hours, less productive though. But yeah, I think I'll just stay for another minute or two in case anybody has any final thoughts for chat. But yeah, thank you for watching, and I'll get those questions resolved and hopefully pick things back up tomorrow. So yeah, we'll just hang around a minute. See if anybody has any final thoughts for chat. And I should totally take a picture holding this thing. This is just one. This is the lightest full-size metal plate, and this is already getting a little heavy. right? Because all we've got is the rails. The rails are light, and this is one stainless steel plate. We have another stainless steel plate that's going to go right on top of this. And then these are 2 millimeters. And then we have 4 millimeter aluminum plates that are going to come up on all the sides vertically. So the shipping box for this thing was 20 pounds, or 10 kilograms. This thing's got some heft to it, and at the speeds I want to run it, it's really going to need it. It's really going to need all the vibration, absorbing, and dampening capabilities it's going to get. So this will be fun. I'll confirm a few details with the creator. His evening, his tomorrow, my tomorrow morning. And yeah, hopefully more ready for tomorrow evening streaming. Thank you everyone. Thank you for watching. Have a good night.